I'll be explaining gear ratios, what they are, how they work, and their real-world applications. Let's start with the basics. Here I have a simple car. It has a motor here and drive wheels here. That's just the fancy word for the wheels that the motor powers, unlike the passive wheels here at the front, which just spin on their own however they want. Now, if I pop off this wheel, we can see the gear setup here. If I pretend to be the motor for a minute and spin this motor gear around, you'll probably notice a few things. The big one is that this gear, where the wheel just was, spins too but in the opposite direction. Now you might have also noticed that they don't spin the same amount. If I spin the little one all the way around, the big one only spins around halfway. Notice how the marks moved. This is because the big gear is 40 teeth and the little gear is 20 teeth. Since they only touch on the teeth, you need 2 spins of the little gear, 20 teeth times 2 spins, to spin the big gear once. But that means that our big gear goes twice as slow as the little gear. Why would we want that? For one thing, this motor is really fast, but it's also pretty weak. Look at it, it's just a little guy. But the gears slowing it down also make it stronger. Let's talk about torque. Torque is like rotational force, or it can be useful to think about as rotational strength. The formula for torque is torque equals radius times force. This fancy letter here is tau, which is just how you write torque on paper. R is for radius, which we can see on the gear here is about half an inch. F is for force. In this case, the force of the little gear pushing on the big gear. This means the smaller the radius, the weaker the torque. Like if you try and open a door by pushing right next to the hinge, you have to push a lot harder than you do on the other side, away from the hinge, which is why people put the handle over there, away from the hinge, so that it's easier to open the door. But back to our little car. The little gear pushes the big gear, which as that force turns into torque, it's multiplied by the radius. If we had a little radius, that wouldn't change much. It might even make it smaller. But because we used a big gear here, it gives a big boost to the force, making the torque on the axle a lot greater. The axle is what's connected to the wheels, and ultimately what makes the car go, so it's pretty important. Alright, so we figured out that bigger gears are slower, but stronger. This also works in reverse. Going from the big gear to the small gear makes the small gear faster. But since its radius is smaller, it's also weaker. What can we do with this information? Well, for one thing, we can make things go faster. Stuff like RC cars or little helicopters have to go faster to work, so they have gear ratios that speed up the spinning of their motors. Things like real-size cars and bikes have shifting gear mechanisms, so that way you can use whichever gear ratio is beneficial for you. If you're going down a hill or on the highway, then you can use something like third gear, which is great for going fast, but it's not great for being strong. Something like first gear is good for going up a hill. It can't go fast, but it is really strong. Use this newfound information to go out there and spin some wheels. Thank you.